really a pleasure to deliver this webinar. And said I'm also a volunteer with the Lean Enterprise Division. So a little bit about my background. So I work with Case New Holland or CNH. I'm the senior manager for continuous improvement for the North American region. I'm also a certified master black belt from ASQ. So for today, my topic I'm going to talk about is quantum computing and really how it can be integrated with AI and applied in the field of manufacturing and how it can help in the future. This is I'm going to call it like more of a futuristic journey that I'm going to take you into. Manny, can you confirm that you're able to see my screen? Please.
Yes, let's go.
Perfect. All right. So let's get going here. So the learning objectives, give me a second here. Okay, it loaded up. Okay, learning objectives, what we're going to talk about is, so there is a Word document that probably Manny will be sharing at some point of time. There's some concepts that I'll be talking about. It'll be good to use that Word document. Manny, if you can take a moment to kind of share that Word document file in the chat or something like that so they can access it. We'll be talking about quantum computing and really the AI solutions that are available out there and really connecting this concept with manufacturing. Where does it really apply in the manufacturing side of business? Talking about the quality and lean applications and really where is this going to be? Where are we going to see this? And what is the future readiness of all this terminology that I'm talking about? So really recognizing the capability of quantum computing and how that's going to be a mega trend in the industrial innovation, really lean formation going into the future. Okay. Forward. Give me a couple of seconds lag here. And I click next. Let's see. Okay. So why does this matter now? So I know a lot of you mentioned about the different areas that you live or you work, but in terms of different industries that have these challenges, really with the global supply chain, the manufacturing complexity is growing enormously. Really what we call as computing power or classical computing power is no longer, we're reaching the thresholds of that. So really the urgency is traditional systems cannot really handle the complexity of our supply chain, complexity of our processes. So really, how do we ensure that there is business value that we create through new and upcoming technology? So even to run some of the AI systems, these say you need some massive computing power. So really by doing this, how companies can gain that competitive advantage and really help them get to that next level. That's exactly what we're going to discuss about a little bit. But before I go jump into the concept, I wanted to ask the group here today is in your process that you work on a daily basis, what is that? Hey, I wish I can optimize this instantly. I wish I can optimize this particular part of my process instantly, whether it's using technology or whether I just need to do some analysis and try to drive that continuous improvement. So I'm going to give a minute or so for the team. If you can look up your chat, there should be like the 3 dots. Once you click that, you should be able to see the chat box open. I'm sure some of you have already used that. So if you can open it up and share, hey, this is a process or this is a decision that I would like to optimize instantly in my current role. Scheduling, that's a good one. Yep.
Sure, absolutely. Yeah, forward. Yeah.
Workshop process. Yeah. There's some good ones coming up. Yep. Cost estimation. Yeah.
Sure. Like we were talking about before, for me, it's if I'm doing a project when I'm down to approved budget, well, I don't commission every time I want to spend cent of the money that's having
tendering loads to carriers. Yeah. I had a short stint in logistics, so I know exactly what they're talking about. This production process.
That's a good one about greedy gossip with projects. Yeah. I've heard that sometimes because people ready to get a responsibility to move. It's then focus on earning it's just more. Wait and do a project.
Okay. So a lot of good feedback here. You're seeing production processes, scheduling, maintenance. In fact, those are some of the very relevant areas of opportunity where there's this huge amount of upscaling we can do in terms of analyses or simulations or coming up with drawing insights, right? So we can make some tremendous leap in those areas. So thank you all for sharing some of that feedback. We're going to go into the first section of, I call it foundations, but then I would like you to maybe use that Word document that manager shared and just navigate through this, because that's just a one pager, but then I'll talk about some of the concepts here. So we just covered how manufacturing is at a limit, right? So when we're talking about large scale optimization struggles and really creating a simulation that's more real time and really understanding what's reality, because simulation is always in a computer. And with the global supply chain, there's always variation, that there's increased amount of variation in our systems, and really cost is becoming higher and higher. And last but not least, something that everybody here should be facing in some way, shape, or form is how volatile our global supply chains are, right? So whether it's at the gas pump or whatever it is, we are being impacted. So how do we optimize our process to reduce cost is becoming more and more the bigger question. Okay. What is Girish trying to say? Why am I trying to create this premise of these challenges? But really what I'm trying to get at is how quantum computing has that power or energy to become a powerful disruptor in any industry, and manufacturing in particular. So when I'm talking about quantum computing, it's really the hardware that I'm talking about. AI is the software, AI or AGI. People talk about this a whole lot. I'm sure all of you are using some sort of a chat GPT or Microsoft Copilot. I call AI as the brain, and the quantum computing is that super turbocharged engine that drives, that really controls that, right? So you got both in motion, both working together, then you got a really powerful system in your back pocket that can propel your industry. So really you're looking at improving the speed of performance, improving the scalability, really expanding that solution space tremendously, right? So how do we process data, and how we come up with some complex decisions using the quantum AI approach? Taking a step back, so what is quantum computing really? So what are we really talking about? So I'm sure all of you are familiar with the traditional binary bits, right? That's used in our computers. So it's a state of zeros and a state of one, which is pretty straightforward. That's how a lot of our computers are built. But in quantum computing, we talk about qubits. The qubits is you got these bits that are occurring in both the state 0 and state 1 at the same time. So that's what's called superpositioning, right? And in quantum computing, you can actually create infinite combinations of binary bits. So really, this enhances the capability to solve much more larger, much more complex problems. So really, you're talking about very intricate issues. So really something that the traditional classical systems cannot solve. This opens up the possibility to solve those types of challenges. So really, this is a more of an emerging paradigm that we are seeing today. So there's tremendous potential, and that's why we're here to talk about quantum computing today. Okay. So I'm going to switch to AI for a little bit here. So what really AI can offer. So broadly speaking, I'm sure there's a narrow AI concept, and there's an artificial general intelligence, or AGI. So narrow AI is typically very task specific, right? So for those in the manufacturing sector, when you have a control system here, it's a machine vision system, it's programmed to do a certain task. It identifies defects running through the line so that it has a certain task, and that's all it knows. So it follows a certain pattern. It requires consistent amount of retraining. So that's narrow AI. AGI is really still in a conceptual state. So you're talking about a system that can think like a human being. So it's a very hypothetical situation where we have a system that possesses the ability to understand, learn any concept, and think and perform the task just like a human would, right? So there is a very high potential for a co-pilot that can be AGI based, that can help us do a lot of tasks that we never imagined we could do. So that is the concept here. That's the AGI-based co-pilot. So really acting as a digital extension or a digital partner in what we do, right? So this AGI-powered assistant it's not just a task-specific tool, but it's actually way more capable than that. So when you think about, hey, I'm going to give some inputs to the system and ask it to design a valve from scratch. So I'm asking it to design an industrial valve from out of nothing, and I just give it some prerequisites, and voila, the system is able to design it from absolutely very minimal amount of information. So that is the co-pilot advantage that we can get. There's also some more concepts out there called adaptive and cognitive AI, which is almost very similar to AGI. Some people usually confuse between the two. Adaptive cognitive AI is really a self-adjusting or self-learning system where it learns real time. So it has reasoning capabilities similar to a human being. It can work with minimal retraining and really mimics the human reasoning, and it's very context-based, and it does interpret patterns quite a bit. So this can be a very useful tool for managers in making some complex decisions. And when it comes to like complex ecosystems, how it can fit into those environments, adaptive cognitive AI systems can really be a game changer. Okay. I'm going to do a quick time check here. Okay. All right. So what am I talking about? When we have this concept of a co-pilot and this adaptive cognitive AI working in conjunction with quantum computing, we have a very powerful system here. So it can have the capability of driving a lot of changes, adding that reasoning layer. So an adaptive reasoning layer where it thinks like a human being, but also has the capability and the computation ability much higher than some of the traditional systems that we have. So it could do real-time optimizations. I know some of you talked about production scheduling or BOM issues, bill of material issues, right? How some of those tasks can be performed instantly in seconds. So that's what we're talking about here. So this quantum computed powered AI system would be a closed loop, real-time system that has tremendous amount of capabilities. And really in a conceptual way, we can talk about several different processes that it can impact. So you're talking about production planning, scheduling that we talked about earlier, maintenance processes, how we can develop predictive maintenance systems, quality control, supply chain routing, considering the complex global systems that we have today. And last but not least is design simulations, right? So really how we come up with complex product designs, understanding customer needs and translating them into actual designs. So this system can be a continuous real-time system, and also it's a closed loop that can help us drive a lot of the manufacturing decisions. Why is this so important today? Because we always talk about in lean and quality is we have to continuously reduce or eliminate the waste in our process, the muda, reduce the lead times, improving our product quality, lower cost, and last but not least, increasing efficiency. So when we talk about all of these primary goals or objectives of the business, some of these systems that we just discussed about, the quantum powered AI, can really serve that purpose and make some of those decisions instantly. So with that being said, I have a question for the group here today. So if you have if you have the capability to run this quantum computing system tomorrow, right? What kind of projects or what kind of huge changes do you envision making, or what kind of impact do you want to make to the business if you had quantum tomorrow? So I want to open it up again. This is our second activity. So if you could open up your chat and maybe share some of your feedback.
For me, I would love to automate some decision personal. For instance, there's a ton of data, and that unless an analyst or an engineer typically goes and gets after it, the data just collects and sits, it does nothing. So that's when we would decide how do we get insights into our process.
Yeah, somebody actually asked a question. Can you provide hands-on examples? In fact, that's coming later. This is a good question. I have a couple of use cases that I would like to share with the team here today. But I also see some really good suggestions that the team is sharing in terms of activities that they would like to probably improve if they had quantum tomorrow. They have the quantum capability tomorrow. Root cause analysis, FMEA, data mining, verified decisions.
I like that iterative FMEA, not just the one and done exercise.
Right. Yeah, so we don't spend hours and hours doing this every so often. So yeah, backlog and rerouting in real time. Yeah, there you go. Somebody wants to get richer. So yeah, it's not a bad idea. It's you use quantum computing for that. Why not throw in all the money? All right, we'll give a few more seconds.
So it does seem like it's people are responding to the idea of we've got lots of data. How do we turn it in information you can get?
And I like the fact that a lot of them are thinking about some real-time analyses. So that I think that's going to be key. So for example, production scheduling, which I'll talk about a little bit, but how some of those instantaneous changes can be made in our processes as our inputs are changing, right? Real time. So that amount of capability, that amount of computational power is what we are talking about, and just scaling up to an entire corporation, it's multi-facility across the globe, things like that, right? So that's where the challenges really becomes multiple fold. So thank you all for sharing this. This is some really amazing possibilities, right, of where really quantum computing can make some pretty significant headway. As one of our participants here today, audience member asked, we will be talking about some practical use cases. So the first one for quantum computing is quality improvement, right? So one of the breakthrough technologies that is coming up through is in semiconductor manufacturing, where there's a huge amount of focus on quality improvement, right? But you're talking about very nanoscale type of defects. So you're talking about nanometers. So that just took a picture of how the modern chips are getting built today. So you're talking about 20 nanometers, which is just like tiny. So nanometers like 10 to the power minus 9. So it's pretty small. So trying to understand defects. I don't know if there are people from the semiconductor industry here today, but you're talking about very highly precise defect detection, very high precise fault detection and identification. So in some cases, much more proactive in nature too, because you don't want to detect a defect and put in a countermeasure, but you want to identify even before the fault's about to take place. So from a more of a proactive or preventive standpoint, that is a problem at hand. So really the solutions that we are seeing today is quantum diamond sensing technology. It's a proven technology. It's probably the most advanced applications in the semiconductor industry today. They call it nitrogen vacancy. So they basically remove a carbon atom from an actual physical diamond, and then that nitrogen vacancy actually is highly sensitive. And that's where it can be used in different applications, like where there's magnetic fields and so on, that can detect very subtle defects, and that's where it finds its application in the semiconductor industry. I know this is all technical, but the fact of the matter is using the quantum science that's available in a rare earth with metal like this diamond, and how we can leverage that technology in creating that sensing capabilities. You might remember I talked about machine vision, but this is another really advanced technology that is being used to improve quality. So the next application for quantum computing, I wouldn't really call this as actual quantum computing. It's actually a quantum inspired application, is in resource optimization. So how do we effectively utilize our equipment in our industry? Because at the end of the day, overproducing or underproducing is still considered as a waste. But how do we improve the efficiency? Here in this particular instance, it's the welding robots of a particular OEM supplier for an automotive industry, how they applied this technology. It's called, as which I'll talk about a little later, is they had this bottleneck in the automotive welding operation. So basically you have the robotic arm that travels, does the welding on the parts. So each path that travels in the three-dimensional space obviously takes time. So how we create that optimal robotic path, so for the best throughput for the machines, right? So that was a challenge, considering the variation in demand, considering the variation of the parts that they produce. So how they used a quantum inspired concept called digital annealer that really takes into consideration over 10 to the power 100 path combinations, which is massive. It did all the optimization of all these robotic paths and really reduced the overall movement of the robots during this welding process by over 40%, and we eliminated the need to buy additional capital expenditure or equipment worth over $50 million. So really a very big impact to the corporation. And really you are talking about a very hugely complex problem here. and how quantum computing along with AI can be used to not only drive efficiency, but also create that cost avoidance scenario for the organization without adding additional resources or additional equipment, which perfectly aligns with the lean philosophy, right? How we try to reduce waste and improve efficiency of our processes. So that's another application of quantum computing that I've seen. What are some of the outlooks here? So we talked about a couple of use cases. We said, hey, quantum coupled with AI has some tremendous outreach. But what's out there? I'm sure that there's not a lot of buzz today. There's not a lot of talk about these technologies, but I'm going to talk about what are some of the outlooks here. So obviously we know with this tremendous amount of computing power, we can perform innovation cycles much more faster. By that, product development cycles can be faster. That can take, traditionally might take years, might be shrunk to like maybe months or weeks. In manufacturing systems, you're talking about smarter manufacturing system, even smarter than what we're doing today. We're talking about Industry 5.0, 4.0. Maybe it's much more faster than that, much more smarter than that. Improving reliability, improving resilience. So different environments, it can still thrive in those changing environments. So that's where the flexibility comes into play. And last but not least, how organizations can come up, really have that competitive advantage by applying this type of transformative technology. So you're talking about lead goals that are improved, quality goals that are improved, innovation that goes off the roof. So really, we are stepping into that factory of the future. Yeah. The future outlook of this technology, honestly, the adoption is still, it's a very emerging technology. Scaling of what we are seeing today, even with those use cases, is in a very smaller scale right now. It has to be expanded aggressively to actually say, hey, this can be applied in so many different industries. There is some investment coming into some of that research going on. There is a significant amount of skill gaps today, right? So when we talk about quantum technology, and especially in manufacturing, so there needs to be probably a very long-term solution that has to be put in place. And I'm almost thinking this would be at least a 5 to 10 year cycle before things come up with more tangible solutions. And so it can be more cookie cutter type of solution that can come through. So with that being said, I want to open it up again for another chat box challenge for the group here today. What really surprised you, right? So what did you feel? Hey, I think this is something that was an aha moment for me when I listened to a couple of these use cases and about this technology. What do you feel is unrealistic? Or, hey, if I were to adopt this technology, what are some adoption barriers that you will face? Or some concerns that you might have from a talent readiness or training standpoint? So I want to open it up again. I don't want to take the same, 5 minutes as it says on the slide, but let's take maybe 3 minutes or so and go from there. All right.
So I had a question. How do people access this? Is there some sort of subscription service, or do people have to build their own systems? How does that work?
Good question. AI systems are being developed. So like I mentioned, the AGI is still in its works, but a lot of companies do have adaptive cognitive systems much more fine-tuned for their business needs. I think that is available out there. Quantum computing applications, as I mentioned, Manny, it's in a much more small scale, right? In fact, this robotic path optimization use case was from this company by the name Fujitsu, who are basically like a service provider for other manufacturing companies. So I think they demonstrated it in a particular application for a certain client of theirs. So very much we are talking about early stages of this technology today.
Okay, interesting. Yeah, somebody did ask a question. I don't know if you were saying with traditional AI, there's sometimes fun with close energy with the world. AI just gets stuff off. So I was asking, is there a similar issue with quantum-powered AI? And do we need people to verify the app that there is a check?
Yeah, again, that's a good question. The concept here, again, the AI is still going to be the brain. So whatever, Jeff, you mentioned here, as far as the human verification of the output, in order to validate the decisions that the AI system makes, or as we develop, right? Quantum is only going to be the CPU, right? If you think about it, it's just that the computational capability is going to be enhanced with quantum computing. That's about it. AI is still going to be the brains. So when we probably think about quantum powered AI, I think the question needs to be asked is how, I'm not sure if the AI system that needs to be built can answer this question. So how do we improve that is our bigger question. The reason I'm really struggling with this question is I'm comparing the quantum computing technology and the AI because we got to treat them separate. Because the AI is always going to be the system that we're going to help, that's going to help us take there. Quantum computing is going to improve our capability by I'm going to throw 10 terabyte or whatever amount of data that's still going to absorb it. So that's what the quantum computing is going to help us do. I'm hoping that answers your question, Jeff, to some extent.
Or somebody else made the comment that small manufacturing companies might not be able to fully manage this technology. But
yeah, that is going to be true for at least for some time. Yes.
So what do you see changing? Is it think that people are going to develop tools to make it easier for small companies to just pick up the tools and run with it, maybe subscription or something else?
Yeah, I see this being this. Some of these solutions are going to be readily available. Like I mentioned, like cookie cutter sort of example solutions might come into the market where people can just say, okay, I have a certain problem. Okay, I can go pick the solution and quantum can help me. Like we talked about, like the diamond sensitive technology, I'm sure companies are going to jump on it and say, hey, I'm going to offer this solution right away. So companies can take advantage of it. So it's like a plug and play sort of an approach. I can see most of that coming through ready available that can open up really huge possibilities.
Okay. Someone else made a comment that really it seems like there's a lot of internal pushback from other departments and stakeholders in the organization. And so that's one of their challenges, organizational culture and resistance.
Absolutely. In fact, that's spot on. I struggle with that too, man. In my organization, to be honest. So yeah, that is a very valid comment in terms of organizational barriers, how senior management looks at some of these solutions and how the organizational mindset is changing as technology adoption rate is constantly changing.
Right.
All right. Another question here, how do QC power requirements compare to AI? So from my research, what I found is it's going to be significantly lesser. So once we start integrating the power of quantum computing to run AI systems, we should be able to find some of that power consumption is drastically lesser. I know water is a big thing now with all the data centers and whatnot, water consumption for cooling the systems that we have today. So I do see with the QC adoption, we should be able to demonstrate a much less power consumption. Good questions here.
Yeah, absolutely. How about the one related to the quantum processing power and will destroy network cybersecurity? I mean, I can imagine that you could really do a whole lot more things faster, like write passwords, for instance.
Yeah, so the cybersecurity, that's something I have explored a little bit, but I think that's something I'm yet to have a really good understanding of in terms of how cybersecurity, because I think that may also be a potential disadvantage. We'll have to understand that a little bit more. I'm going to make a note of that. But yeah, good question, Alexander, in terms of how it can affect the network cybersecurity. I don't have a good answer for that one.
I think it's like anything else. As new tools are developed, there are people trying to figure out how to use those new tools and they're just focused. So I'm sure this won't be any different.
I'm glad I have this esteemed audience here today. Some really good comments, good challenging questions as well. I think what we can probably do is in terms of in this particular topic that we are discussing about, I wanted to take a little bit of a segue into, all right, while we talk about this technology, we do understand it's in its infancy stage today, but the capability, as we just discussed about, is vast, is huge. So from a conclusion standpoint, what I wanted to talk about is, I know one of our audience members did mention about trying to get that buy-in from leadership. So really understanding, hey, what are all the inputs, how we can make some transformational change by applying some of these technologies, even AI, just only AI for that matter, not even quantum, because quantum it's much more, you're talking about short term to long term, and we're still trying to explore what are some information out there where the companies or organizations can make quantum partnerships. Upskilling is going to be a huge challenge, like I mentioned before, how companies have to prioritize upskilling people and really having manufacturing leadership. I'm sure they're always challenged with multiple priorities, whether it's safety, quality, productivity, cost, or customer. But how do we embrace technology? And that only comes by when people start understanding technology. I just read a paper a couple of days ago. No matter what technology we put in place, it all depends on how much your frontline leadership absorb that or really appreciate that, right? Because at the end of the day, we can come up with all these bells and whistles. When you go out to the manufacturing shop floor, nobody cares about it. The thing's just going to get a layer of dust over a period of while and things just fall off the grid, right? So you might have spent quite a bit of money on it, but we got to get their buy-in. We got to get their partnership at the very beginning. So really having their engagement very early in the process. So from a leadership standpoint, some of the key takeaways I would say is getting some actionable guidance, providing them that the messages saying that, hey, you need to act now, not later, in order to get that competitive advantage and really help developing those strategic planning processes, right? Whether it's AI-based solutions or even the power of quantum computing. Okay. We talked about a lot of different things, but the biggest takeaways I would say for the group here today is how quantum computing we know as of today is really it's not just going to be speed, but also it's going to help rethink complexity, really process complexity. So for manufacturing industry people or any industry for that matter, we always talk about excellence in lean, but how quantum computing powered AI can change that landscape, right? So this is almost like a once in a generation opportunity that we're going to see that can really redefine operations and innovation for that matter. So really we touched on the future readiness of this particular technology that's out there. So those are some of the key takeaways that I wanted to share with the team here today. And those are some references. And finally, that's my email address. If you're willing to talk more about it, I know there's a lot of good discussions on the chat we had today in terms of discussing about, hey, what's out there? What are some of the issues that we're facing and how quantum can be a solution for some of those challenges that you're facing today in your industry. And also, what I really do appreciate is some of the team members here do have that understanding of quantum computing. So there are some challenging questions, which I'm going to go back to the drawing board and try to figure it out. This is good input for me before I make this presentation in WCQI. So I really do appreciate all of your participation here today. Again, I want to, since we have a few more minutes, I still want to open up for some questions. I think we still have another, 8 or so minutes. I want to see if maybe we can have another 5-minute Q&A session or something. I don't know, Manny, what's your thoughts?
Sure, absolutely. You've got the time. May as well use it.
Yeah.
I'm trying to think, just in terms of practical applications. I know you mentioned a few of them and they sounded rather good. Do you see this as being, you mentioned that purposes for processing wafers as this, or with 10 to 100 possible S combinations, and this quantum computing obviously cuts through, allows me to evaluate a lot of. Where else will people use this personally, do you think, or is this more of a company?
Yeah, that's a good question. Certainly, usually the business need usually drives some of these technologies to scale, right? So only then we can even think about how we can be drawn into more of a personal to addressing personal needs. But certainly, I'm pretty sure solutions will come up in the future that can be a little bit more smaller scale that can address some of our personal needs as well. The one opportunity I do see with Industry 4.0, we talked about how there's going to be more amount of mechanization, more robots, more equipments. But then in 4.0, 5.0, we started, okay, these equipments are going to talk to each other, right? That's where we are opening up the opportunity for, hey, what is that limit? What is the computational limit? Because now we need machines to interact with each other. We need the equipments to be agile for these different changing environments. So I think that there's going to be that business need driving this technology initially, Manny, and then we'll probably see more smaller scale solutions from a personal standpoint.
Interesting, especially with the power requirements. That's huge. As we all know, data centers are pretty much in the news. We need them for more than just creating recipes.
Yeah, I'm seeing a question. So how far away is AGI? It seems several years away. It'll be much longer. Quantum computing could help but isn't practical quantum computing even further away. So AGI, from what I know, is actually, I'm going to say probably even less than 5 years or even less than that. But quantum, yeah, we got to give it a little bit more time. I think I mentioned before, I'm going to say 10 years or a little bit more optimistic, a little bit more aggressive, 5 years. They're talking about a little bit more missions on the quantum side.
Okay. Anyway, I don't know if you heard my question, but you've got Claude, Gemini. So you already got the AI tools that are people using. Are those organizations looking towards integrated quantum computing better, or is it a different group of companies that's doing that?
Yeah, there is quantum research happening even in some of the big tech companies right now in terms of finding applications. But I chose manufacturing just from the standpoint, my background, I was trying to research a lot more on the manufacturing side of the applications. But there is a lot of research happening for other industries as well. Yes.
Okay. Somebody asked about RUs. Yeah, we will be sending out RUs within a week of this webinar. So you'll see it in what. Also, too, I asked Jody if she could send out the glossary as well. So anybody who didn't pick it, we'll get that again. Okay. So I don't know, is there a killer app for this? Do you see something that's just, boy, hey, we'll apply this to that problem?
Can you repeat that? Was that for me, Manny, or is it for the group?
No, that was for you. Well, I'm just asking some really killer app. Like I'm thinking about something like, how do you solve linear programming when you're trying to crunch through a bunch of constraints for variables. I don't know. Have you run across anything? It's just, wow, it would be cool. It's today, but we'll
Yeah, absolutely. Yeah, you said linear program. Yeah, in terms of linear programming. So we typically would call like some of the problems, like there's this particular set of problems called as NP-hard problems. So you're talking about non-deterministic problems that are very complex in nature. You got multivariable situations, right? In those cases, you're stretching the limits of how computational or how you can come up with that solutions or how we can come up with those insights. So that is right area for this type of a technology to come in. In fact, aerospace, right? If you think about aerospace engineering, that's probably the most complex product development, process development scenarios we have. So how this type of technology can penetrate and really be disruptive, right? In terms of, because there's so much amount of regulatory practices, whether it's in safety, whether it's in quality, there's so much constraints of how they do this, how they manage, and how this type of technology can help them advance, maybe do that innovation cycles in much more faster or solve problems much more faster, something that might take hours or days. They're able to run those simulations in like seconds, right? So that's what we're talking about. I think that's the capability we're talking about.
Sure. And you mentioned non-deterministic systems. Yes. We're thinking like weather forecasting. Right. Now we get markers. We can do it now on a sort of simpler level, but I like the idea of being able to handle complex systems and really optimize. Somebody mentioned zero processing earlier. So zero optimize for properties and specifications. I'm thinking like, for instance, maybe we introduce some defects and variants because it slows a response, perhaps. It's going to provide some benefits. But that's exciting. I think a lot of complex systems, whether being a big logistics, I could even see it's like the traveling salesman problem. All both pretty
right
in computer science. So just imagine you've got all sorts of customers and deliveries and stuff on the end. I am VR can handle right now, or I'm just loading them that. It could be more allergic. You'll have to run it overnight right down that. So I think that's cool.
Yeah, weather is a really good, it's a huge problem to solve in terms of the variables, the locations, the factors that play into it is, certainly that would be certainly a good opportunity to maybe we can leverage using this technology in the future. Yeah, it's sounds exciting. Yeah, for sure.
Sure, I'm trying to figure out where else to use it. I don't know. I guess it's name.
So question for the audience, was that handout that Manny shared, was that helpful? Because I did go through for somebody who's not been exposed to these topics that we talked about today. I'm just looking for some feedback. before my WCQI session. So if anyone can just kind of, okay, I know one of you just said it was helpful, so thank you for that. So I just prepared that ahead of time because I felt a lot of this is, some of them may not be exposed to this. So maybe I'm just going at a certain speed that you may not be finding it so much value adding. Okay, thank you. I think that was good feedback. So appreciate the feedback there. All right.
Well, I think one of the nice things for you from your perspective is you're presenting this in front of the professional audience before a conference. So perhaps you'll get some insights out of this, or some people will reach out to you with other comments later and you snip it down.
Yeah, absolutely.
Somebody did ask if they could share some slides with their college students. And I suggested just so reach out to you, they like it, and blah, 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 all of those I'm interested in.
Perfect. Okay.
So I'm sure you would know something.
Yeah. And Manny, is that a way I can get some of the chat messages, the feedback? Maybe it's extracted, or there's no real way to do that?
Yes, sure.
Download it. Okay.
We'll have to wait for the webinar to finish processing.
Yep.
I'll do that.
All right.
And also, what we will be doing too, I don't know if you paid attention to the Tintel incident, but one of the things we do is take an hour-long webinar and cut out all the, can you hear me now? Can you see my screen? Stuff. Really knock it down to 30 to 45 minutes then, and we'll chapter it so it's a tight presentation. So you'll be able to use it for your own purposes. Either go in your personal brand or have a tool to provide to other people so they can see what form. Like I'll cut out all the introduction stuff that I did in the beginning. Probably this part right long, full. So it'll just be focused on you and the fact. Somebody did comment that were very nice to have a glossary, so then that would bite us able to write down.
I thought, yeah. Thank you for that feedback.
So that's good. So I guess you're going to be doing the same thing at the conference. You got to provide this as a link for download.
Right. Yes. You're right, Manny. Just to give them a little bit of a heads up of it's coming. So, yeah.
Sure. So I'm obviously one of the coaches of the other speakers, but if I don't have a conflict, I will certainly come and sit in on your presentation.
Yeah, I'll be glad to have you, Manny.
Sure, absolutely. So not a problem there. So we've got a couple of minutes. I don't know if there's any sort of final thoughts you want to add, or you just bust out one.
Yeah, really my inspiration was really trying to bring something to the audience that's more cutting edge. I had my concerns about, is that going to help like anybody and everybody in the group? But it seems, I don't know how many actually showed up in the group here today. I know Manny said it was over 150 registered, but from the amount of information we got in these sessions that we had, it just, I'm very pleased in terms of the amount of conversations and some of that questions and feedback we got from the team. I'm really glad to get this esteemed audience here today and the amount of feedback we got. And that's why I was curious to even maybe steal some of the comments, and that'll be notes for me as well. So again, thank you for all of your participation.